is the seconds needle, right? So this is the seconds needle, and it rotates. Okay. So similarly, like this one, this phasor is also a rotating vector, right? So this minutes needle of this clock, right? It has some length. Okay, it has some length and it is rotating, right? So similarly, phasors have a magnitude, a length, and then it rotates, right? So the angle we take is called this omega t, right? So let's say that if we have a rotating vector this, and its magnitude is how much? E naught, right? This is E naught, and this is making an angle omega t, right? So this is the magnitude of this vector, and this is the angle it is making with this horizontal, right? And it will have a vertical component. So we talked about this vertical component, right? How much is this vertical component? That is r sine theta, right? This we understood, right, in the previous class.
Yeah, sir.
So similarly, this magnitude is E naught, right? And this angle is omega t. So what would be this vertical component? Yeah, let me write in this way that you have, let's say, this is theta, this is r. So what was this component? This was r sine theta, right?
Yeah,
This
sir.
Similarly, you have this E naught magnitude, this angle. So what would be this component? Magnitude is E naught, which is r, right? So E naught and sine of theta, right?
Yeah.
So
Sine
the
theta. Yeah.
yeah, so theta is omega t. Like, this is the angle it is making, right? So sine E naught sine theta, whatever is the magnitude r and sine theta. So the vertical component, when you drop this phasor vector on the y-axis, so that will give you the instantaneous voltage, right? So what are phasors? Phasors are rotating vectors which behaves sinusoidally, right? And they can give you the, so these phasor, let me again write the definition of phasor. So phasors are rotating vectors which behaves sinusoidally, right? They are pictorial, or they are very useful tool to understand combination combinations of different subjects. Right. So these phasor are geometrical representation, and they are very useful when we want to determine the magnitude, we want to determine the instantaneous voltage, or when we want to determine the current and voltage relation. So these phasors are very useful. Okay. These are rotating vectors. So let's say this one is in here E naught, and if I rotate this one with, let's say this is So this is your E naught, right? This is your omega t. And if I rotate this vector in this way, right? So I have taken this vector and rotated this with 90 degrees. So this would be how much? This would be E naught and sine omega t plus 90, right? This is how much? This is E naught sine omega t. And I have taken this vector and rotated up to this point. So I had initially my vector was this, right? This was my vector, rotating vector, and I rotated this vector by 90. So now this has come to this point, right? This length is same. So this length is E naught, right? And I have rotated this vector by 90. So now my instantaneous voltage will change, right? So that is what they use, or that is why these phasors are very useful. So did you understand the phasor part? Yes? Yes,
Yes,
B,
sir.
yeah, did you understand about this phasor part?
Sir, can you repeat again?
Yeah, so did you understand about this phasor part, phasor diagram? Did you understand about
The, can you explain it one more time?
Okay, so let me, yeah, let me just start. Let's say you have this x, y, z, right? And you have this vector which can be rotated. So now let's say this is making an angle theta and its magnitude is r. Okay. Now you
Yeah.
can what you can do is that you can rotate this vector and you can bring it here. So this would be again r, and you have rotated it by 90 degrees. And then what you do is that you again rotate this vector in here. So you have brought this vector, its magnitude will remain same, right? This is the
Yeah.
length of this vector. So its magnitude will remain now, but it is making a different angle with the y-axis, right? So
Okay.
this, yeah, in here this was r sine theta. So when I drop down this vector to here, so this was r sine, right? Now when I drop down this vector to the vertical, so this would be how much? R sine and theta plus 90 degree, because I have rotated this vector by 90 degree, right?
Yeah. Okay.
And when I want to calculate the vertical component of this vector, so this is r sine and theta plus how
Plus
much
90.
degree? Yeah,
90, 90.
so 180, right?
Yeah.
So these are called the phasors. They are behaving like sinusoidal function, right? So these are vectors which are sinusoidal function, and they are rotating vectors. So those are called the phasors. Did you understand that?
Yeah, sir.
So and these are very useful in understanding the combinations of so in understanding the relation between the voltage and the current in a circuit. So if you want to understand about the voltage and current in a circuit, we can draw the phasor diagram of both these ones. Yeah, just remember that the vertical component will give the instantaneous movement. So now let us make the actual diagram that we have this phasor whose magnitude is E naught and the angle is omega t. So then vertical component would be E naught and sine of omega t.
Oh my God.
So vertical part will give you the instantaneous here, right? So that is the use of this clear.
Yes, sir. Yeah, sir.
Okay, so then and then let us understand about the graphs, and then we'll talk about the different combinations of circuits. So then we'll talk about the resistive circuit, then we'll talk about the inductive circuit, and then we'll talk about the capacitive circuit, and then we'll combine all those circuits. So before we do that, this phasor was important, right? This is important, and then the second important thing to understand is the graph. So let us understand about the graph. So first, let us understand about the graph of sine, right? So let's say y is sine of, let me write it as 4 sine x. Okay, this we have already understood, but yeah, let us understand it. Y is 4 sine x, right? This is y, x, and this is y, which is 4 sine x. So let us find this value at 0. So at 0, y would be 4 sine of 0, right? So sine 0 is 0, so this would be 0. This is now at 90, at x equals to 90, this is y 4 sine of 90, right? So now sine of 90 is 1, so this is 4 into 1. So this at 90 would be 4. And then at x equals to 180, right? So at 180, again, sine of 180 is how much? This we have done before,
0.
right? Absolutely right. So this is 0. Oh, so this is 0. So this would be 0. So this whole thing. And again at 270. So at 270, this would be y 4 sine of 270, right? So this is 4. Sine of 270 is minus 1. So this would be minus 4. So this is minus. And then again at last you have this 360. So again at 360, this would be y of 4 sine 360. So this would be simply how much? Again, this is. So this is the graph of 4 sine. These are the points. Then we have to make a graph. So highest is 4, lowest is minus, right?
-4. Yeah.
Let us make this graph in here. This is let's say 4. This is 4 line, and this is minus 4 line. This is the maximum and minimum values, right?
Yeah.
This is 0. This is
5.
90, right? Which is pi
Yeah.
by 2.
5. Yeah.
And then this is 180, which is pi.
5.
Then this is 270, which is 3 pi
E
by
by
2.
2.
And then this is 2 pi.
2 pi.
These are the values on which we have to plot. So we have at 0, this is 0. So we are here, right?
4. Yeah.
And at 90, it is 4. So we are here. So we go from here to go from here to here, right? And then we again come to at
0.
180, we again come to this. And then again at 270 we go. So
0.
at 270 we go minus 4,
Minus 4.
right?
Yeah. Yeah.
So minus 4. And then again at 360 we go back to. So this is the graph of 4 sine, right?
Yeah.
This we have done several times. Now let us understand about the graph of cos x, right? So let us understand about the cos. Let us write 4 cos. Okay. So let us find out the different points. This is how much? Zero, 90, 180, 70, and 60. So at 0, x equals to 0. So y is 4 cos 0. Cos 0 is how much? Yes,
1, sir.
cos 0 is 1. So this would be, so this is
4. Yeah. 4.
and at x equals to 90. So y is 4 cos 90. Right? So cos 90 is 0, right? So this
Yeah.
is 4 into 0. So this is 0. So this is 0 at x equals to 180. So y is 4 cos 1. Cos 180 is minus 1, right? So this is minus. This is minus 4. And then at x equals to 270. Again, this is 4 cos of 270. So at the multiples or the odd multiples of 90, cos is 0, right? So this is again, we have 0. And at x equals to 360, again we get back to the initial point, right? So y is 4 cos 360. Cos 360 is 1, so this is 4. So now let us draw the graph of this y equal to 4 cos. Again, the maximum point is 4 and minimum point is minus 5, right? And the points are, let's say, 90, which is pi by 2. So let me write it as pi by 2. 0, pi by 2, pi, pi by 2, and 2 pi. So these are the values, right? These are not equal, I guess. Okay. So at 0, this is 4, right? So at 0, y is 4. In here we are starting, right?
Yeah, sir.
And at 90, and 90 we are going 0. So we are right. And then at 180 we are going again in here, right? So minus 4. This is minus, right? And then this is going 0. So now it has started to, so it is increased, right? So it will go to 0. And then it is going to 4 at 3. So then it will go to, not a great thing. Uh, let's say this is Like, okay, this is at 2 pi, again I'm getting, right? So this would be the graph of power, 4 power. So are these graphs clear?
Yes, sir.
Yeah. So, and the last thing that we will need, last thing that we will need is this. So one is this power factor, right? And that is represented by cos of phi. Okay, so we'll talk about. Okay, so now we'll talk about, yeah. But before we do that, please note down these parts. Right? Move down these parts, and then we'll talk about the different circuits.
Sir,
Yes,
what's that? Phasors are rotating vectors which behaves.
sinusoidally, right? So they are the sine function, right?
Okay.
Sinusoidal functions. Sinusoidally meaning sino, so that sine function. So all these are sine, right? Sine, sine, sine. So with the help of phasors, we can calculate the instantaneous EMF, and we can also see the difference between the two phase difference between the two vectors, right? So whenever you have noted it down, please tell me so that I can.
Yes.
Yes, noted.
Just a minute, sir.
Yes. Should I scroll down? Just noted. Then part.
Sir, a little up.
Yes,
Yeah.
a little up.
Scroll a bit up. Yeah. Yeah.
Part.
So diagram. Yes, sir. You can scroll up.
So this is just to show that how can we get the instantaneous EMF from this phasor, right?
Yeah. Yes, sir. You can scroll up.
Yeah. So just from these, right? We have to make a graph of y equals to sine, right? I can zoom out. Whenever you want me to scroll down,
No, sir, it is go now.
Yes, done.
Yes, sir.
Now let us talk about. So we have talked about the EMF, right? So let's say that we have a circuit and then there is current which is flow, right? So let's say that let us draw the phasor diagram of current as well as this EMF, right? So phasor diagram of current and let's see. So we already know that the EMF generated from the AC supply, AC generator is this one, right? It has an magnitude E naught and it has an angle omega t. So this is the phasor diagram of the voltage, right? This is what we get from the AC generator, right? AC supply. Now let's say that you have a current which is with a different phase, right? So it has a different angle. So let's say that this has some angle like this. This is the current. Let me write it as this one is. So this is I now, okay? And let's say that this angle is phi. So how much would be the total angle? How much would be total angle?
I not sin omega t.
No. I naught sine omega t. That is, you are nearly there. So uh, this would be E naught sine omega t, right?
E naught. Okay.
So this would be E naught sine omega t. But for the case of I, what is the angle that this I is making? What is the angle that this I is making?
90 degree.
90. So this is omega t. How much is this total angle? This is the angle that I naught is making, right? This is the angle, right? Total angle. So you have this angle. From here to here, this is omega t, and then here to here, this is phi. So total angle is how much,
Omega t plus 5.
right? And this is
Yeah.
your I. So what would be this instantaneous current? That would be I naught sine and whatever angle is.
Omega t plus 5.
So this is the instantaneous current, right? This is the instantaneous current. And you can clearly see that there is the phase difference, right? So there is a difference of phase in E naught and this I naught current, right? So this is your voltage, this is your voltage, and this is the current. So from the with the help of the phasor diagram, right, we can clearly see that this is E naught and it is making omega t angle, and this current is phi angle ahead, right?
Yeah.
So the angle difference or whatever the angle difference is called the phase difference, right? So phase difference between current and this voltage would be how much? That would be phi. This is the phase. This is part clear.
Yeah, sir.
This is not clear.
No, no, done, sir. Clear.
Yeah. So this would be called the phase difference, right? So we can see that this voltage and this current are at different angles, right?
Yeah.
So this would be the phase difference, and from this phase difference we define a factor which is called the power factor. So power factor is defined by cos of this phase difference phi. So this is called the power factor. Okay,
Yeah.
and this determines that how much power has been lost, right? So this is a determination of in different circuits how the power is dissipated, right? So this is determined by this power factor. And then you have this power average, right? Average power. And that is denoted by P, this notation. And this is given by VRMS, IRMS, and cos of this phi. This is how we write the average power. Okay. All through this phase difference phi. So phase difference is the difference between the voltage and the current. Okay, clear? Is this part clear?
Yeah, sir.
Yeah, so please note down this part and then we will talk about the difference. When we know these things, then we can clearly understand about the difference. Okay, we have noted it down now. Whenever you have noted it down, please.
Done, sir.
Now, what we will do in the next set of sections that will add some AC supply to different circuits, and then we'll see that what happens with this voltage and current. Are they do they have some phase difference? What is the power factor? What is the average power? So all these things we will calculate. So first would be the resistive circuit. Resistive circuit. What we are doing? So we have a resistance, and then we are supplying an AC voltage to this circuit. So let's say we have this voltage which is V naught sine of omega t. So this is the kind of supply that we are providing. And this resistance has a, this conductor has a resistance R, right? So we know that this is the AC supply because DC supply is like this, right? This is whatever supply we get from the cell, so that is the DC supply. And whatever the supply we get from generator, so that is the AC supply, right? So this is behaving like sinusoidally, and this is some constant number, right? So this is a constant supply, this is a sinusoid. And in this supply, we are connecting a resistive circuit. So now what would be the current and what would be the phasor diagram of this resistive circuit? So let us try to find it. So we know that voltage is how much? In a resistive circuit, voltage is IR, right? Yes, Mir,
Yes, sir.
this is the voltage in the, and what is the voltage that we have supplied? So this is V naught sine of omega t that we have supplied, right? So the ultimate aim is that we want to find out the current in every case, right? So this would be how much? Current would be V naught by R and sine of omega.
Sine omega t.
So let us, this is a constant number. So let us say that this is I, right? So this would be the current and this is the voltage supply. So is there any difference of angles between this one and this one,
No, sir.
right? So the phase difference phi would be, right?
Zero.
Phase difference would be. So, but let us, yeah, so first let us draw the phasor diagram and that would be given over here, right? So that is how this phasor diagram is very important. Phasor diagram. So we have this voltage supply which is V naught, and this is with the angle or with the phase omega t, right? So this is our V naught sine omega t, right? Right? And then with this same angle, there is this current. This is I naught. So this would be I naught sine of omega t, right? So we can clearly see that there is no phase difference between I and between E. So no phase difference between current and right. So we can write, and when we want to draw the graph of these two functions, right? So we can also make the graph would be this is 90, this is 180, this is for 270, and this is 360. These are the angles, right? And we know that what are the maximum values of, so what are the maximum values of voltage and current? So for voltage, maximum value is V naught, and minimum value is minus of V naught, right, Mir?
Yes, sir.
And for the current, maximum value is how much? For the current, what is the maximum value? What is the peak current? From this function, what is the peak current?
V not sine omega t from the phasor
Peak
diagram, sir.
current, peak.
Uh,
No, no. So peak current. You have this current function, right? So what is the peak current? Let's say you have this voltage. So what is the peak voltage? This is the peak voltage, maximum voltage, right?
yeah. Okay. V
And
not.
yeah,
I not.
so similarly, peak current would be I, right?
I not. Okay.
So the maximum value of current would be how much? I naught, and the minimum value would be minus I. Understood?
Yeah.
And we know the graph that at 90, so at 90, sine would be maximum, right? At 90, at 0, sine is 0. At 90, this would be our sine function, right? And at pi, this is 0. And then at 3 pi by 2, it is going again minimum. And at 2 pi, it is 0. This is the graph of sine, right? That we have already understood, right? Please.
Yes, sir.
And then we have to draw the same graph. So this is V naught sine omega t. Now we have to make the graph of I naught sine. So at 0, this is 0, right? I is 0. And at 90, this is I, right? So this would be this. And then at 180, this is going right. This is this, and then at 3 pi by 2, this is going here. This is here, and at 2 pi by it is this is the graph of I naught sine. Okay, when the voltage is reaching maximum, the current is reaching maximum. When voltage is reaching minimum, the current is reaching. So they are in the same phase, right? However, way the voltage is varying, the current is varying with the same. Is this clear?
Yeah, sir.
Yes, me it is. Is this graph clear? So if this is not clear, then we can draw this. Right. This is our V and this is our I and this is our, let's say, theta or omega. So for 0, this is 0. For 90, this is V naught, this is I naught. For 180, this is 0, this is 0. For 270, this is minus of V naught, minus of I naught. For 360, this is 0. This is So these are the two graphs that we have found, right? And we can clearly see from here, that I naught is V naught by R. So R is greater than 1, so this I naught is smaller. That is why I have drawn this I naught as smaller, right? So I naught value is smaller. I naught value is smaller than V naught. Okay, understood?
Yeah, sir.
Okay, so then please note down this part and then we'll write about all these other. So these phasor diagram and these graphs are very important. And whenever you have any doubt, please ask. Okay. It's
Sir, can you scroll up? Just, just a minute. Yeah, sir, you can scroll.
done.
Yeah, this is it.
This graph, yes, this graph part
Yeah,
is also
this
there.
is left.
Then it is yeah. What did we?
Sir, just the graph is left.
Oh, graph is left.
Yeah.
Yes, whenever you have
Yeah, sir, done.
then what did we understand? So we understood that what did we understood that we had a voltage supply which was this, and then in the resistive circuit we got this current, right? Where this I naught is P naught by. This is the first thing that we got. Second thing is that there is no phase difference between the current and voltage in resistive circuit. This part is very important, that in resistive circuit there is no phase difference between current and voltage. That is, phi is right. Then third one is that what is the power factor? So power factor, which is cos phi. This would be cos of 0. So this would be 1. So power factor is 1 in resistive circuit. And then fourth one is the average power. Average power is how much? So this is P bar, or this is also called P net. Okay. This is VRMS, IRMS, and cos of phi. So cos of phi is 1, so this would be simply VRMS and IRMS. And you already know that what is VRMS? Me, do you remember what is the RMS value? RMS value is related with peak value, right? So what is VRMS? Yes, remember, please.
Can you repeat, sir?
Yeah, so what is the RMS value when you have this peak value, P naught, then what would be the RMS value?
Um,
That would be P naught by root, right? So
okay.
similarly, IRMS, that would be I naught by. These RMS values are related with peak values, right? So this would be V naught by root 2, I naught by.
Root 2.
This would be V naught, I naught divided by. This
Root
is
2.
the, yeah. So these are the informations
Sir,
that
what
we
about the
get
root?
from the resistance. Yeah, so root to root 2 multiplied.
Oh, okay.
2 into root 2 is out. That
Okay,
is
sir.
good. Yes, please note down these four things which are very important in resistive circuit. So we will calculate all these things for different circuits, right? So we'll talk about the inductive circuit and then we'll talk about the capacitive circuit. So yeah, we'll calculate all these.
Okay.
Please note it down. Yeah, whenever you have noted it down, please. Yes, done. Meet.
Just a minute, sir.